Now let's move on to something much more practical: how we handled the sync to async conversion during the migration process. At the beginning, before we had a solid approach, this part was extremely painful. Every place in the codebase that used a synchronous loading API had to be modified. Every call site, every wrapper. It was time consuming, risky, and honestly not scalable. Eventually, we found a much cleaner solution. In our project, we were using YooAsset, but the same idea applies if you're using XAsset or any similar resource framework. The first step was simple: switch the editor into web play mode. Then, at every synchronous load wrapper, we added logging. Why? Because when running in web play mode, if a synchronous load fails, it throws an error. With proper logging in place, we can immediately see which resource triggered the issue. The key is to centralize logging at all synchronous entry points. That way, when something breaks, you don't have to guess. The log tells you exactly where the problem is. Once we identified the problematic resources, the next question was, why does synchronous loading fail in minigames in the first place? The core reason is this: asset bundles cannot be loaded synchronously in the minigame environment. They must be loaded asynchronously. However, and this is important, once an asset bundle is already loaded into memory, loading assets from it can be done synchronously or asynchronously. That part doesn't matter. So the real requirement is ensure that the asset bundle itself has already been loaded asynchronously. Once we understood that, the solution became straightforward. Before any synchronous asset load is triggered, we make sure the corresponding asset bundle has already been loaded asynchronously at an earlier stage in the lifecycle. In practice, after identifying the problematic resources through logging, we located an earlier initialization stage, before those synchronous calls execute, and inserted a unified async preload step for all asset bundles that would later be accessed synchronously. That's it. As long as the asset bundle is loaded asynchronously first, the asset bundle is not unloaded afterward, then all existing synchronous load calls can remain untouched. No need to rewrite business logic. No need to refactor core systems. The original synchronous APIs continue to work because the underlying asset bundle is already resident in memory. This approach allowed us to fix all synchronous loading errors very quickly. It was minimally invasive, highly efficient, and avoided risky modifications to existing logic. And in large legacy projects, that makes a huge difference.